This is the second video in our series on mutual TLS, and today we'll be covering how to secure your certificates and keys in the system keychain. So let's take a look at the certificates and keys that we generate for our example. So we generate two CA certificate authority certificates, and here's the commands we're going to use. And notice an addition from last time is we simply pass in all the extra information on the command line. So we have the CA certificates for the server and the client, and they come with their own private keys. Now these private keys should be secure. These are very important to secure because if a bad agent has access to those, they can use those to issue their own certificates. And they'll look like valid certificates to your ecosystem. And those keys should be secured outside of your normal systems. There should be in a dedicated secure key store. So then we generate our TLS certificates for the server and for the client. Also here we pass in some additional information, including the common name. And one thing to note is we need to set the expiration date to be 398 days or less, because macOS Keychain, if it sees a longer expiration, it will not think that this certificate is valid. So we need to create a legal certificate, and that is the current maximum age of a certificate, of a TLS certificate. So we talked about the keys. They should be secured outside of the server-client system. Next, we have the server. So the server, of course, it needs to have its own certificate. Let's look at the files. So we have the server TLS certificate and the server private key. So those need to be on the server, and the server needs to secure the private key. In addition, the server will need to have the CA for the client. So it'll need the CA certificate for the client. But on the server side, the most important thing to secure is the server key. I think I was clicking up here, but yeah, this server certificate and the server key. So the server key needs to be secured. So now let's talk about the client. So in this case, in this example, our client is going to be a macOS, and we're going to use the system key store of the macOS, which is the keychain. So the things that we're going to put on the keychain is the client certificate, the client key, the server CA, so that way the keychain can see the server certificate as valid. And then in addition to that, we're going to put the client CA as well. And this is just for validation. So that way the keychain, if it sees the client CA, it can validate the client certificate. So we've generated the certificates using this script. And just as an example, I can go ahead and run it. So this is the gensert script. Genserts. And I basically regenerated all the certificates and keys. And now what we want to do is we want to import these into the Apple's macOS keychain. So I've written about the keychain before, and at a high level, it's basically the macOS's method to track and to protect secure information such as passwords, private keys, and certificates. So we're going to use a script to import everything that we need for our client. And it's going to be done with this import.sh script. So we're going to import the server CA. So that way our macOS client can see the server as valid. We're going to import the client CA just so that we can verify the client TLS certificates. And then we'll import the client TLS certificate and the client private key. And we're going to be importing all of these into the system keychain. Now there are other keychains like the login keychain that you can use, but for this example, we will use the system keychain. And the system keychain is available to all users on the system. So we're adding some additional security switches here. We are passing this -X switch, which means that this key cannot be exported. That means once we put it in the keychain, users and applications can see that there's a key in the keychain, but they can't actually export it. They can't read it. The way they access it is through Apple's APIs. So they tell Apple to verify it or to sign something with it, but they cannot actually see the key itself. Another interesting thing we pass here is we use this -T switch to tell right away which applications can access this key. So here I just put 3. I put Curl, Safari, and Google Chrome. Now, these can be added later, or if you're using a new application that's trying to access this key, macOS will give you a pop-up saying this application is trying to access the keychain, and you can enter your username password at that point. Okay, so we went over the script, so let's go ahead and import and run it and import all these things into the keychain. So the script is import.sh. And we got a permission error because when importing into the system keychain, we need to use high privilege. So let's do sudo. And it looks like it's asking me few times, probably because there's a few things we're importing. Okay, so we've imported, we've generated the certificates, we imported them into the keychain. So as an extra step, let's verify some of these certificates. So first, let's verify the server certificate. So we imported the server CA. And what we're going to do here is verify the server certificate. So let's run this. So we're giving this verify cert command the server certificate, and the server CA has been imported. So this server certificate is verified against the CA. And it says the certificate verification is successful. And there's some additional information here that that we can ignore for now. The other thing we want to verify is our client certificate and key. Now, if the keychain has a certificate and a private key that match, and it's able to match them because the certificate contains the public key. So it's possible using mathematics to match the public key and the private key. So if the keychain sees both of those, it combines them into what's known as an identity. So what we can do is we can run this command, find identity, and the type of identity we're looking for is an SSL client. And we can run that, and we see that it found this identity, test client TLS. And this is the common name that we gave the certificate. And it basically says that this is a valid identity. And part of the reason why it says it's valid is because it also knows about the client CA. So now we're actually ready to run our servers. So let me open a new tab here. And let's go to my directory. And just as in the previous example, we're going to use Docker to create two NGINX servers, one for TLS and one for mTLS. So I'd simply run docker compose up, and it's going to run two servers, one for TLS, one for mTLS. And now if we use curl to access the TLS, let's clear this. We use curl to access the TLS. We don't need to tell it about the CA because the server CA has already been imported. So we just run this curl and we say, and we get a response. And curl has a verbosity switch -v. So if we run it with verbosity, we actually see that this TLS handshake is happening. Now let's try running curl using the mTLS server. So instead of 8888, there's a 9 at the end. So let's run it, and we see that it's not actually working. And if we run it with verbosity, we see that the handshake is being attempted, and we do see that there is a certificate, a client certificate that's being requested, but it looks like it's not being sent. So what seems to be happening is that curl doesn't currently support using the system keychain for the client certificate. And we can see the version of our curl by running curl -- version. We do see it uses secure transport, which is the an Apple API, but apparently it doesn't support client certificate, unfortunately. Now, Safari, on the other hand, let's try Safari. Let's Safari, let me open a new window in Safari. I'm using private browsing, and well, let's do TLS first. So localhost 8888, hello world. Okay, it's complaining that we used HTTP and not HTTPS. HTTPS. I thought it would automatically use HTTPS, but I guess not. So we specify HTTPS now, and we see TLS hello world. And now let's try to access the mTLS server. And we see this pop-up. It says that our server requires a client certificate. So this is what we're looking for, right? And if we click continue, we'll go through and we'll see our message over here. So in future, if we want to go to this local host, Safari remembers which certificate we want. So we won't need that pop-up. Another thing, as you remember, is we specified Safari as one of the applications that can access the private key or interact with it. Can't access it because we specified -x, so it cannot be exported, but you can access it via the Apple APIs. And Google kind of works a similar way. It also has a pop-up that you can pick. So all of this code is on GitHub. So I will put a link in the show notes. And in the next video, hopefully we'll get to creating our own mTLS client using the Go programming language.